Hello, everyone, and welcome to today's webinar. Today's webinar is a continuation in our series. This is part 3 of our series in building machine ID for Milturn machines. And this is again being presented by Marina Vilkina. She's worked very hard at these, and she's done so far an excellent job presenting these webinars. But before we get started, I'd like to just make one more little announcement, is that it may be January now, but May is coming up a lot quicker than you think. So please, we have our SolidCAM World in Istanbul, Turkey, and we'd like everyone to register for it. So get your registrations in as soon as possible so we can make the appropriate plans. And there's a lot that we will be doing there. A great venue has been already planned out. So register as soon as you can, and hope to see all of you there. Okay, let's get back to the webinar now. So Marina, I will now make you presenter,
Thank you,
and you
Sydney.
can show your screen.
Okay, showing my screen.
I see it. You can go ahead.
Okay, thank you very much, and hello and welcome to the webinar. The topic of today's webinar is the submachines. I will finalize both machine ID files which I started during the previous session. And the first machine will be the QuickTech Milturn machine. Let me consider what submachines should be added to machine ID based on machine kinematics. I'm going to the software and I will open the tool table to show you what we have in machine kinematics. I created during the previous session, I created the 3 turrets inside the machine ID for the QuickTech machine. This is the rotary turret. Here it is. It is quite common type of turret and quite common kinematics for the operation. It can be applied for the both spindles. Also, I have the linear turret here. It's a lower turret in a gantry. It can provide the toning operations, OD and ID toning, and the most complex is the B-axis turret because it can rotate and provide a tool change during the rotation and during the moving by Y-axis. I will remind you a little bit about the axis structure of this machine. The subspindle of this machine has 2 axes. It has X-axis, so it can move towards the main spindle, and to provide the operations on the turret and the back spindle, I should move the back spindle right opposite the main spindle. And also I have the Z2 axis here. I have the normal 3 axes on a turret. It's X-axis, Z1 axis, and Y-axis. And also I have the Y2 axis on a gantry and a B-axis. Only for my 3rd turret, it's a B-axis turret. Now going back to the submachines. As I said, we have 3 turrets here, but one of the turrets, the rotary turret, can operate on the both spindles. That is why I will need 4 submachines inside my machine ID file. Let me go to the machine simulation to make it completely clear what operations will be presented for each submachine. Because some of these operations will need additional MCO operations inside a COM tree. For example, I can't provide operations on a back spindle without part transfer. and I will need to position the back spindle right opposite the main spindle to provide the operations with the rotary turret and the back spindle. So what I have here, the first submachine with which I will create will be the submachine is the I will have the turret, rotary turret, and the main spindle there. So it's a normal operation, quite common frequently for the turning machines, lathe machines. Then I will have a transfer, and after transfer will be provided, I can add and I can have operations on a back spindle, and the operations on the back spindle will be divided on 3 submachines. The second submachine will be the rotary turret, combination of the rotary turret and the back spindle. And after that, I can provide operations with the linear turret and back spindle. And then the milling operations, only milling operations with my B-axis turret and the back spindle. So I will have to create 4 submachines which should support all these types of operations. Now, let's check what we need to define a submachine inside machine ID file. We will have to pass through 4 steps. First of all, we should decide what combination of turret and table should be inside the certain submachine. Then the type of operations which we let to be inside the submachine. As you saw during the simulation, not all the turrets of this machine provide all types of operations. Some of them provides only milling operations, some only turning, and some provide the combinations from milling and turning operations. Then we should define the vectors of the coordinate system of the submachine. This is very important step. These vectors will define the signs of the coordinates in the trace output. Then the last step is the axis order, extremely important step, and during today's webinar I will show the different combinations of axis order and how it will be outputted and how it will influence on the operations. Now I will open the machine ID file of the mill-turn machine, which I started during the last session, and will add the submachines. I added an empty submachines, and now I will fill the submachines which I created. As I said, we will have 4 submachines here, and the first one will be the combination of the rotary turret and the main spindle. It is important to name your submachines to add a good name to the submachine, to realize what operations will be inside the submachines, it will be comfortable to use them inside the software. Then the third step is the operations type. I know that it's a turret with drive unit, so I can have the both types of operations, milling and turning inside it. Then I need to position my coordinate system. It is quite important thing because here it wouldn't be 0. I have an angle for the turret, and my coordinate system for this submachine should have an angle too. So I will rotate it a little bit on a 15 degrees. It's an angle of the turret inside it's a machine construction. So I will add minus 15 degrees here. It will be rotation around Z vector. The last step here is an axis order. It is for this particular submachine, it is quite simple because all axes are obvious. So I have Z1 as the Z linear axis, Y linear axis, X and C axis. The only thing I don't want is the C axis inside the turning operation. We never use the C axis for the turning operations for such constructions. I can go further to the second submachine, and this will be the turret and the back spindle. I will name it as a turret and BS, and it has milling and turning operations again, but my coordinate system will be different because I will have two rotations here. The first one is the rotation according the station of the subspindle, back spindle, and a rotation according the x vector of the turret. So I will make 180 degrees rotation around x-axis, and because it will be opposite, I will have to add it like a plus 15 degrees. Then the axis order, it will differ, but not so complex, because for this submachine, the z-axis is the axis of the turret. So it's Z1 will be my Z-axis, Y will be Y of the turret, and I will use X-axis as the axis of the turret. My X2 axis is not used as the kinematic axis inside this submachine. All I need to do before I'm going to add the operations inside this submachine, I need to use the MCO operation to position my subspindle to the correct X coordinate. It should be right opposite the spindle. They should have the one Z axis. And what I can do also, I can position it in the right Z axis if I don't want to use it as a Z reference, if I would like to move it closer to my main spindle. But these axes, they can't be used inside the operations. They are not kinematics. They just to position my stock, my part. So the heel axis will be the axis of the turret. So it's axis of the turret, and I have to use C-axis as the axis of the subspindle. And again, I don't use C-axis for the turning operations. The next submachine, it's a combination of the linear turret. It's a lower part of the gantry, and my back spindle. I will name it as a linear and BS. And for this particular turret, I don't use milling operations. I have only turning operations here. My coordinate system will be different again. I will have it as the station on a subspindle and as the X vector for the OD turning. So I will rotate my coordinate system because by default it is positioned as the machine orientation coordinate system. I will rotate it around the x-axis and add a rotation around the z-axis. And my axis order will be simple because I don't use turret here. I will use only axis from the second channel. It's Y2 axis. Y2 axis is the axis of the gantry. I will remind it, axis of the gantry. Here it is. It is used to change tools and during the milling operations. X2 axis is the axis of the spindle. It will be axis used for the turning operations, and Z2 axis to position it and to to cut during the turning and milling operations too. And of course my C2 axis, and again I don't use it during the turning operations. And the last submachine is the combination of the axis turret, the upper part of the gantry, and the back spindle. B-axis and back spindle. And now I know that the only operations I can do for this submachine is milling operations, no turning operations. Here my coordinate system and axis order will be as for the lower turret, for the linear turret, especially coordinate system. So I will again make a rotation of the coordinate system. And for my axis order, I can see that I have a longer list of the axis, but I will fill them all because I'm still using my y-axis. B-axis for this case will be second rotary axis, and depending on machine modification, it can be indexial or simultaneous. It depends on the machine model and on the CNC controller type of it can be Mitsubishi, Fanuc, and with different modifications. So it depends on the specification of the machine. I will have my X2 as X-axis, Z2 as Z, and C2 first rotary axis. What I can see here, I will refresh it a little bit. And here, when you created it as a default, you can see all your submachines positioned right in the machine zero, machine orientation point. In fact, they should move automatically. So you should have here, you should have the coordinates of the station on the back spindle, because the part table for this submachine is the back spindle. There is a little trick to move the coordinate system to its position. I'm just close this and change for a second the coordinates, and then I will get it right on their place. I hope so. So here they are. Now they are in their correct place, and here I can see my coordinates, and this is coordinates of the back spindle station. The same I will do for the turret main spindle submachine. I should move my station of the main spindle, for example. And I have my coordinate system in its place. So we can see here that the coordinate system of the first submachine, which consists from turret and main spindle, it has an angle. It is the same as the angle of the two vectors. And I have three coordinate systems here. This one, we have a function show only. So this is the coordinate system for the operations on the back spindle with the turret. And this is my coordinate system for the linear and for the B-axis turrets combining with back spindle. Okay, here I have two headers. It's a channels and access pattern. I will delete the previous content to show you how to add channels to machine ID files. Inside the channels, we should apply the number of axes we are going to use, the linear axis and the rotary axis. And we should add submachines which should be used inside the VMID file. This is very important. Depending on the submachines you add here, you will have the list of the operations inside the synchronization table. It's a table which is showing what output you will have. So depending on the submachine and the channel to which it is added, you will have the operation in these channels. It will appear here. Okay, so I will add a channel. I know that this is 2-channel machine, so I will add them both. And here we have the channel name. It is, in some cases it is important, in some it is not, because some customers prefer to output files using their channel number or channel name. For example, for the Mitsubishi CNC, they always use this sign and the name of the channel, the first or the second. And so I will use these signs for both machines, which will be considered today because their both has the Mitsubishi controller. In some cases, you can leave a word here and do not out it to the name of the file. So it depends on the situation, but it's not critical. And of course, you will see this name inside the synchronization table. And here you should set the number of axes you're going to use in this channel. It is better to have more axes here and to not forget about some axes that can appear here. So I will set like a 6 and 2 axes here. And now it is important to add submachine. Do not forget add submachines inside channels. I know that the first channel operates with the turret and all axes connected with turret. So I will add turret and main spindle submachine and turret and back spindle submachine. All coordinates of the back spindle, I mean X2 and Z2, are rated with the second channel, but turret and back spindle does not include these axes. They include only X2, Z2, and Y2 axis. And for the second channel, I will add this name again, and the number of axes will be 4, and the number of rotary axes will be 2. And the 2 submachines connected with the gantry is the linear and B axis and back spindle. The last header I have here is axis patterns. There are no special axis mode for this particular machine, and I will use after generate axis pattern function. So I have it here, just right click and after generate axis pattern. And this will be quite enough for this machine. The next machine will have more complex modes. So that's all for the machine. I will attach the machine assembly, 3D assembly, so you have a possibility to repeat all the steps and create the machine with yourself. Now let's go to the next machine. It's a Swiss type machine, and I would like to remind you their machine structure and its facilities. I will go to the next project and just remind you what access it has and what tools it has and what it can do and what it can do. And I would like to add that this machine has a special function as a exchange access, and we will consider how to create the access pattern for this situation. So let's consider the tool table and tool facilities for this machine. Frequently, submachines for Swiss type machines are not so obvious as for the Milton machines. For example, you have a lot of tools here, and as I said during the previous webinar, they can be changed. So these blocks can be here, or they can be put to other places, or they can be replaced with other types of blocks. So you have a lot of different combinations of tools inside all Swiss type machines, and you can divide all tool blocks and create as many turrets, as many blocks you have, or you can divide tools according drive units or according access distribution. For this particular machine, I created three turrets, three tool blocks. So I divided all tools I have here on 3 blocks. Because the 3 submachines is a minimum number for this machine. I will explain what I mean. So here I have the tools, the group of tools, which can operate only on the main spindle. It's OD tools, radial milling tools, 3 positions, and these 2 attached blocks. The upper row is the milling tools, so it's axial milling tools. The lower row is the turning tools, but mostly they're used for the turn drilling operations. And of course, you put the ID turning tools here too. So these tools can operate only on the main spindle. I have the same block and 6 position of tools, like back tool post, I can call it like that. So it doesn't make sense. The sense is that the upper row can has a drive unit, so it's still milling tools, but they can operate only on the back spindle. The lower row is still turning tools, and again just for the back spindle. And the third turret here is the separate turret, not driven only with turning tools. Here we can see it's a quite common situation when I'm using the ID turning tool, and I will use it for the OD turning, the out turning. And you can put some drilling tools here or one more OD turning tool, but the space is limited. So in most cases, they set the only one OD turning tool here, and other tools are used as a drilling tools. So I divided all the tools on 3 groups, and on the previous session I created 3 turrets here. It's a gang back spindle and T21-24 back spindle. Why I can create it like that? Because all this construction, my 2 upper turrets, gang and gang BS, they are moving with the same axis, and they are set on the machine based on one device of the machine. So I have Y axis here, X axis for the turning tools, and that's all. My Z1 axis is the axis of the stock. So I have 3 turrets here, and I will have 3 submachines according these turrets. Let me add a couple of comments about these tools. Programming process for back tool post can really differ for Swiss type machines. You will need to analyze and see code examples to create submachine for back tool post operations. I will go back to my presentation and just show you the code example from this particular machine. current machine needs access exchange procedure to provide back-tool post operations. There is a special G140 code. You can see it here, G140. Which lets first channel to operate with access from the second channel. So it says that from this line, I will have my Z axis on the first channel as a Z2 axis from the second channel, and I can't have Z axis on the second channel after I added this line. And my C axis is a C2 axis from the second channel. That means that after this line, I can, if I will add any lines with Z and C, machine will move Z2 and C2 from the subspindle. What else it means for the programmer, for the operator? It means that I can't operate during I have my operations on a back-tool post. I can't have my Z and C operations on the first channel. Z1 moving the stock and C1 rotating the stock on the first channel. So I don't have the operations during on the first channel when I have operations on a back-tool post here. This is a special facility of this machine. Some other machines can combine these operations if they can divide this access inside. But this machine needs access exchange commands to operate. And after I will finish, I will add the special code to cancel this mode. It's G142. Oh, you can refer to the Mitsubishi manual, and I believe there are more explanations if it's not really clear. So now I'm going to my machine ID file, and we'll add submachines to 3 submachines according 3 turrets. So the first submachine will be the combination of the gang and the main spindle. I will name it as gang and main spindle. And I know that I can have both operations, milling and turning. The upper tool block is for the OD turning, radial, axial, and ID turning, all types of operations. And here I will add my coordinate system. It will be the same as the coordinate system of the machine itself. So I will have my x-axis directed as it directed on the for the tools for the OD turning. Y and z-axis is directed like that because of our new rules. In the older versions, you can have it you can have the opposite direction for the z-axis. Axis order will be quite simple. I will have my y1 axis. So y-axis will be provided by y-axis of the machine, x-axis, and z1 axis, which can be seen here because I don't have stock here. And I will skip the c-axis for returning operations. Then I will add the second submachine. It's a combination of gang BS, which includes these 6 tools. So these tools, I divided this gang tree on the 2 parts. The first one is for the main spindle, the second one is for the back spindle. But technically, it's they are set on a one device. Technically, it's the one turret. But in terms of machine ID file, I divided them to have a possibility to add different facilities to this submachine, and to have a possibility to operate with this submachine separately inside the SolidCAM. So I will add it as gang BS. I will use the back spindle, and I will add the name BS and BS. And again, I have both milling and turning operations here. The upper row is for the milling operations. The lower is for turning operations. My coordinate system will be different. It will be aligned as in the tools inside this this tool block. So I will rotate it to have the z-axis be orientated as the axis of the station of my back spindle. I will rotate it around the x vector. And the last step is very interesting. It's axis order. Again, if I'm going back to the code temple, I know that here I will have my y-axis from the first channel, x-axis for the first channel from the first channel, z2 axis and c2 axis will be from the second channel. I can't use x2 axis here. Before using these tools, I have to move my back spindle to right opposite the main spindle. Then I will call the tools, or I will call the tools first in position. It depends on the scenario which is used on a plant on each particular machine, and after that I can apply this mode. But before it should be applied, the subspindle should be positioned right opposite the tool which will be used. So this tool should be in its correct position. It should be, for example, in one line with the axis. So the axis order will be I will use the Y1 from the first channel, X1 from the X1 from the first channel. I will not use X2 axis. I will use Z2 axis and C2 axis, but only for the milling operations. And the last submachine is the submachine from the combination of these turning tools and back spindle. So I will use it as T2124 back spindle, and I will name it accordingly. And I know that these tools are only turning, they don't drive unit. I have to rotate my coordinate system again, and to provide the turning operations, I have to rotate it as x vectors of these tools. I will rotate it around x-axis to have my z with the correct direction. I will have my z vectors from the both spindles. They will be differ, so it will be like minus z according to the main machine orientation. And also I will rotate it on a 90 degrees around the z vector. And my axis order is very simple because I will use x2 axis as x, z2 as z, and c2 I will not use. I'm not going to use it. Okay, to not spend the time because in some reason it takes time to add a new channel, I will use that channels that I created before. So the first channel, the number of axes, and what I'm gonna do is just add submachines. The submachines with I have three submachines here, and only one submachine is used for the second channel. The first two submachines are controlled completely with the first channel. So I will have a gang main spindle here and gang back spindle. And for the second channel, I will add only submachine which is controlled completely with the access from the second channel. I will delete access buttons here. Hope it not takes for a long time. Oh no, it will take. So I'm going to, so I created the normal button again with the after generate access button function, and I will add an access button, special access button, to have a possibility to machine with these tools. I can call it the special mode or G140 or whatever you like, but I name it as a special mode that will be used for this operation. I will go back to my presentation slide, and I should change it. So here most of the access are controlled with the first channel, and I should let my VMID file and solid to control the access from the second channel on the first channel. So what I have to do is I have to add X2 access, Z2 and C2 axis. I can't control X2 axis, so I make it forbidden. I have Z2 and C2 on the first channel, and I can control C2 during this on the second channel. I have my Y axis, X1 axis here. I don't use Z1 axis because this mode is not for the stock on the main spindle. It is just only for the back spindle. So I don't use Z1 because I have Z2 here, and I don't use C1 here. And for the second channel, I can only use my X2 as normal default. And maybe I can control Z2 here, but it's not makes sense because everything which is going during this mode can be with back spindle and these tools. I can't have any operations on the main spindle during this process. So I will show you how it works during the simulation. You can see here that I don't have a lot of operations inside COM3. So the first 3 operations is with gang main spindle submachine. Then I will have the transfer. I can't use the last 2 submachines without transfer. I'll making cutoff, transfer. Then I'm going to have the turning operation on the submachine, and then after the movement of the stock to its position right opposite the tool, back tool post, I can use milling and turning operations here. I'll just show very quickly machine simulation. It is very important to use the combination from the axis order, axis buttons, and special MCO operations, because you should understand what machine needs. It really depends on the programming type of machine. So here I will have the normal combination, which every Swiss type machine has. It's moving by Z1 with stock, and X1 and Y1 and C1. This is my normal combination. Drilling operation, whatever. And then I will have my cut-off operation and part transfer, and now my part is in the sub spindle, back spindle, and I can provide operations on the 2 tool blocks. The first one is for the turning, so I have a turning operations here, and then I will just go back. I have to move. You can see X to position a special MCO operation inside the tree. I should position my my part right opposite the main spindle, because I can't operate with X2 inside the first channel. I can do this only in the second channel, and I will have in the list of the operations in synchronization table, I will have this operation on the second channel. And after that, I can apply a special my submachine, a GANK back spindle, and then I can provide milling operations, turning operations, whatever I want in this mode. And for this mode, I can only have it without y-axis. So like in Cartesian or polar coordinates. And if we will take a look on the synchronization table, channel synchronization, you can see that the first channel, the second channel, and in the first channel I have my turning operations, then I have my transfer, then I have the only one carding operation. It's a turning operation on the back spindle. Then I position my sub spindle right opposite the main spindle, and then I have the milling operation on the first channel, but in fact it is applied with Z2 and C2. And if I right click here, I will have my GANK PS pattern, but here, for example, I will have my normal pattern. After that, I'm doing the safe retract of the stock to have a possibility to change the tools, because I have no idea how long the drills will be out from the tool block. So I'm doing Z retract. I can do it to the Z home position or certain position, whatever I like, and then I'm going back and apply special mode again. Then I can do injection or some other operation. For example, I can go back to my tools from the third submachine and continue. So that's all for today. During the next session, I will show how to add MCO cycles to machine ID files. It's very important. There are several important things that that you should know about this process, and I will tell you about the difference between MCO cycle and with full trace and without full trace. I will show it how it will influence on the code. Thank you for your attention.
Okay, Marina, thank you very much. That was extremely informative. And this, again, everybody, this has been recorded and will be available to everyone later on. So we'll meet you again, see you again at the next webinar. And again, I'd like to remind everybody, please sign up as soon as you can for the upcoming SolidCAM World 2020 in Istanbul in May. All right, take care, everyone, and have a fantastic weekend.
Bye.
Bye-bye.